All right, so before we get into actually configuring stretch networks in NSX-T in a federation design, we need to take a minute to talk about some of the implications of the decisions that we're about to make in the GUI. So let's get to that. Now, I created this drawing that depicts my lab. I have two sites. I have San Francisco's data center here. I also have the Los Angeles data center here as well. Now, what I will be doing is creating this T0 that stretches across all of these sites. So that T0 will essentially have interfaces that live on edge node 1 here. It'll have an interface or interfaces, plural, that live on edge node 2, and the same for 3 and 4. Now, this T0 will stretch across all of these sites, meaning I can now connect workloads to that T0 at any site. And workloads can move, so VMs can vMotion between sites. They can stay connected to that same T0, or if I have a T1, to that T1, right? Now, from a routing standpoint, we're going to be running BGP from the T0. Now, it will be setting up BGP neighbor adjacencies, essentially, from each of these edge nodes. So everywhere I have yellow will be basically a BGP neighbor relationship that will be established. We will get to that. That is coming a little bit later. But I want to specifically talk a bit about the routing implications when we create a T0 and some of the things we have to decide as part of creating that T0. So let's do that. Let's pause. Don't think about this segment for now. We will get to that. Now, specifically, let's talk about these new decisions that you have to make when you're setting up a T0. Some of these are new things that you haven't seen in NSX before, so that's why I want to talk about them. The first thing you need to decide is the availability mode. This isn't new. You should be familiar with this. You have the choice when you create a T0, do I want this to be active-active or active standby? Now, the implication here is if you do active-active, you can't do stateful services. So NAT, load balancing, maybe load balancing is a bad example. Gateway firewall, DHCP server. So all of the stateful services, if you want to do those, NAT is really the biggest one. You can't do active-active. So that will possibly drive your decision. But when you think about this in terms of federation, when you hear active-active or active standby, think about one location. When you go to create that T0, if you hit active standby, you're saying, I want each location where this T0 stretches to be active standby, or I want every location that this T0 stretches to be active, 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 and I just hit my mic. Please ignore that. Moving on, we have location preferences, the next thing we need to decide. This is also very new to NSX and can be really confusing, so I'm going to try to make it simple for you guys. Location preference really just decides how will traffic egress from my NSX-T federation design. So specifically, we're saying, do we want traffic from, maybe we have our two sites, right? San Francisco, Los Angeles. Do I want traffic from each site that is connected to that same T0? Do I want it both to just egress together, or locally at each site, straight out to the internet, for example? Or do I want it to maybe hairpin over to one site and then go out? That's the choice we have to make. And I'll explain why one makes sense over the other. So the first option is called all primary or all primaries. This means that traffic will exit each location locally. So there's no hairpinning back to one site or anything like that. If you have 4 locations, traffic egresses at each 4 locations. Now, why wouldn't I want to do the all primary option? The biggest reason is that if you do this option, you will have asymmetric routing. This means basically traffic will go out one way and come in another way. And it can be a little bit unpredictable. So the issue there is if you have stateful firewalls, for example, they'll only see half of the connection and they'll block it. So you will have issues. So that's something to consider. And there's another thing I will bring up that is very key about that option, but we'll talk about it as part of this next one as well. So the next one is primary secondary. So primary secondary basically means traffic for all locations where this T0 is stretched will egress from one location. We'll call it the primary location. So if I have 3 locations, I'm going to say one of them is primary, the other 2 are secondary. The secondary locations for anything connected to that T0, only that T0, will go something like this. It'll basically leave that location, go to the primary, then out to the internet from there. Now the benefit here, of course, is no asymmetric routing. Traffic will go out through that primary location and in through that primary location. I'm not breaking stateful firewalls. I can also do stateful services, NAT, for example. So let's take a look at a graphic that I think will make this a little more clear if you are finding yourself a little confused. All right, so let's start with that first option, T0 all primary or all primaries. You might see it written different ways. In this case, we have 3 locations, and we go into NSX-T in our global manager, and we say, let's create a T0. That T0 exists at 3 locations, And basically it will instantiate this on all of these edge nodes here. So we've now got it. And again, keep in mind, it will either be active or active standby, depending on how we set up that T0 from the beginning. That's out of the conversation right now. What we're talking about is traffic flow. So in this case, if we do all primary, we say, okay, I want this site to be primary. I want this site to be primary. And yes, I want this site to be primary as well. From a traffic standpoint, as I said, this one is really simple to understand. Traffic will egress from each site out and straight out to the internet. That's all there is to it. Now, one of the biggest reasons you wouldn't do this, in addition to the asymmetric routing, is that you can't do any services on this T0. So you can't do NAT or gateway firewall, things like that. You can't do that. So you lose that ability, so you have a loss of some control and functionality if you go with this option. Now let's take a look at the other option, the primary secondary. So this option starts out looking just like the other one. We have our 3 locations. Now we have our T0, we configure it. And again, active for the T0, active standby, doesn't matter. That's only deciding how it looks within a single location. Now in this case, we say we want to do primary secondary. So maybe I'm going to do NAT in this case. And I say, you know what, San Francisco is going to be my primary site for that T0, and the other 2 sites will be secondary. From a traffic flow standpoint, traffic will all leave from those hosts that'll hit their edge nodes locally, just like it does with regular NSX-T. But this time, the edge nodes will route traffic over to the primary site, and then it'll go out to the internet. And I know the drawing here is horrible because it looks like it just goes over here into nowhere. But essentially, it's going from this edge node or these edge nodes to these edge nodes in the primary, and then out to the internet in this case. And the same would be true for the other site as well. And for traffic for San Francisco, traffic would just egress locally. So there's some considerations here. Obviously, the benefit here is you can do stateful services if we do this design. Now, I do want to show you a packet that I captured from my design. So basically, this is a packet generated by a VM. In this case, it was inside of Los Angeles, and the VM source IP was 100.113. I went into that VM and I issued a ping to 8888, and this is the result I got. What I did is I actually captured the packet over here so we can see the source IP is 100.11 and the destination is 99.11. So the reason we have 2 IPs here, if you remember from our overlay networking conversation, is that these are essentially, this is that Geneve encapsulation happening right here. Now the encapsulation in this case, 100.11 is the remote tunnel endpoint or RTEP for one of these edge nodes right here, and the destination here, 99.11, is one of these RTEPs. So basically what it's doing is it's encapsulating it here, sending it over here to these edge nodes. They're going to strip off that encapsulation and then route it out to wherever it's going, out to the internet or wherever. So hopefully that makes sense. Now there is a great design guide. I will actually share a link in the description that you can check out. It is amazing as far as coverage goes of routing. Specifically, it talks about if you're doing this mode, active with all primary or whatever the case is, how does routing look? Where are the routes shared, what will advertise what, that sort of thing. So it gets into that. To be honest, it's a very thorough document and it's not something I could cover in a 10-minute video, so that's why I'm not going over that. I hope this was helpful. In the next video, we'll go over the actual implementation of a T0 that is stretched across multiple sites from scratch. So I'm looking forward to it, and I'll see you there.